All right, but anyways, finding inverses. Let's go. All right. The first step you're going to want to do is to swap x and y. All right. And the second step is you're going to want to solve for y. And the last step is going to be rewrite in function notation. All right, so let's go ahead and do these 3 steps with this lovely quadratic. All right, so first thing we're going to do is swap x and y. So let's do that. We got x equals y squared minus 2x plus 3. This is our first step. Our second step is going to be solving for y. So what we got to do is we got to complete the square. And you know what? I miswrote this. It's supposed to be a y. It'd be like that sometimes. All right. So now we got to complete the square. So x equals y squared minus 2y plus blank plus 3 minus blank. So what goes in these blanks? You might ask, what goes here? I'm confused. What you're going to do is you're going to do b over 2, and you're going to square it. That's what goes there. Let's find out what this is. B is negative 2. So we're going to have negative 2 over 2. And you're going to square it. So this becomes negative 1 squared, which is just 1. So that's what goes in here, is 1. So now we have to factor this. So we got x equals y minus 1 squared. And we got plus 2, because 3 minus 1 is equal to 2. All right, so my mic cut out here, but I'm just solving for y, and I know y'all can do this part, so yeah, sorry about that. Now we're going to add 1 to both sides, so we get 1 plus minus x minus 2 equals y. And that is solving for y. All right, and the last thing we got to do here is we got to rewrite this in function notation. So instead of writing y, we are going to write, because we have g of x here, we're going to say that the inverse of g to the negative 1 of x, is equal to 1 plus minus the square root of x minus 2, and this is our answer. So that is finding the inverse of a function algebraically. All right, so our next example here is verifying that 2 functions are inverses using composition of functions. So you might be wondering, what is this? Well, let me give you a reminder. This is when you put one function in another. So what this looks like is, instead of h of x, every time you see x, you're going to put in g of x. So instead of h of x, you have h of g of x. All right. So every time you see x, you're just going to put g of x in instead. And vice versa, you could have g of x. So you could have, g of h of x. So every time you see x, you're just going to write h of x. So let's go ahead and find h of g of x. All right, and we want these to be equal to x. That's how you know that these are inverses. All right, so we got 2 times, here's x. So instead of writing x, I'm going to write g of x. So we have the cube root of x plus 1 over 2 minus 1. And this is cubed. We got x cubed, so this cubed. Now we're going to have some cancellations, or some simplifications rather. So these simplify. We get 2 times x plus 1 over 2 minus 1. And then these simplify. So we get x plus 1 minus 1. These simplify to 0. So we're just left with x. So that is h of g of x, and it's equal to x. So this is good. All right. So let's check the other one. So g of h of x. That's going to be equal to the cube root of, well, here's x. So instead of writing x, we're going to write what h of x is. So this is 2x cubed minus 1. Now we're back to g of x plus 1 over 2. So instead of writing x, I just wrote h of x. So now I'm going to do some simplification. So these should simplify, and we get the cube root of 2x cubed over 2. These simplify, so now we have the cube root of x cubed. These simplify, so you're just left with x. And since both of these are in fact just x, we're done, and these two are compositions. Via composition of functions, we have verified these two functions are inverses.